Welcome to springlib.
We have the sequence an given by 2 to the power of n plus 5 times the nth power of 3. So let's compute the first few elements. So a0, we just replace every n with 0, so that's 2 to the 0th power plus 5 times 3 to the 0th power. So this is 1 plus 5 times 1, which is 6. Similarly, we compute a1 to be 17, a2 is 143, and a3 is 421. Now we are asked to show this recursive property of the sequence, which is an is given by 5 times the previous element, so an minus 1, minus 6 times the previous element, so an minus 2, for every n greater or equal than 2. So to do this, we just write the right hand side, so 5 times an minus 1 minus 6 times an minus 2, and we just replace the definition of an. So this is 5 times, and this is by definition 2 to the n minus 1 power plus 5 times 3 to the n minus 1 power, and then we have minus 6 that multiplies 2 to the n minus 2 plus 5 times 3 to the n minus 2. Now we multiply everything. This becomes 5 times 2 to the n minus 1 plus 25 times 3 to the n minus 1 minus 6 times 2 to the n minus 2 minus 30 times 3 to the n minus 2. And now we essentially want to factor the powers of 2 and the powers of 3. And to do that, we observe that 2 to the n minus 1 is equal to twice 2 to the n minus 2. And similarly, 3 to the n minus 1 is 3 times 3 to the n minus 2. This way we can factor out the power of 2 and minus 2 and 3 and minus 2. So let's do that. Let's factor out all the coefficients in front of 2 to the n minus 2. Then there becomes a 10. And then we have minus 6, 2 to the n minus 2. And then we have plus. And now we factor out the coefficients of the power of 3 and minus 2, which is 75 minus 30, 3 and minus 2. Now we do these sums here. So this is 4 times n minus 2 and minus 2 plus 45 times 3 n minus 2. Now 4 is 2 squared. And then 45 is 5 times 9. So it's 5 times 3 squared. Then multiplies 3n minus 2. And now we can collect all the powers together. So the first is 2 to the n. And then we have plus 5 times. And the power of 3 is 3 to the n. And this is by definition an. And we're done.